All right, hello everybody. Welcome to class today. You should be able to hear me right now, just based off of my OBS. Before we get started today, does anybody have any questions about assignment 9, I guess? I know some of you have gotten started on that, and I know that we also have a test coming up, so some of you may not have, and been working on that, and no worries. If you're studying for the test, I completely understand. I am just wondering if any of you do have questions that I can help you with. So let me know, and I will stop and take a look. Today is a review day, so I have uploaded some things to Web Campus, and we're going to go over those today. But before we do that, there's just a few kind of housekeeping notes that I would like to address. So we're going to go ahead and get started since it is class time. And hopefully more people trickle in here, though it is a review day, so I won't blame anybody if they think that they don't need the review. So to get started, I graded assignment 7 just this morning. I'm getting caught back up. Thank you all for being patient with me on that. So you should all be able to see your assignment 7 grades. And to be honest, I was very happy. I was very happy to see how everyone kind of did on that assignment. A lot of people seem to have done well. For those of us who were maybe struggling before a little bit with the pointers, it seems like we've kind of gotten the hang of that too. So I think overall assignment 7 went a lot better than a lot of the other assignments we've had, so I was happy to see that. One thing about assignment 7 that's been different from all the other assignments, except for the one you're working on right now, assignment 9, was there was a write-up at the bottom of that PDF. So here it is, right? Which I just asked you to put in either a Microsoft Word document or a text document. And this is not meant to be offensive at all, because I type in Notepad every day. You guys know that. And so if you want to send me the text file, in fact, it's kind of easier for me, because I grade all of your assignments by pulling the code into VS Code just like this. And so if you happen to submit a text file, I can actually just drag the text file in here, and I can read your answers. Otherwise, I have to open up Microsoft Word, but it's not a big deal. So do whatever is comfortable for you. I'm just letting you know that if you're trying to be formal, you know, because this is a college class, I'm not too worried about that. That's all I'm saying. And so some of you guys will have gotten docked some points for that write-up. That write-up was a percentage of the grade. And so as of right now, I'm just going to answer some of those questions for some of you that got that mixed up. And if you're wondering why points were deducted, hopefully you can see why. So the first question is, what line of code makes the bucket class abstract? Well, we talked about this before, and it is in the virtual notes, I assure you. In fact, we can go take a look at that. I don't see why not. Let's see how we're doing. Maybe I'll pull this off to the side. What is that? Those are operators. All right, and here we've got some notes. So let's see what we've said in this notes here. So here we can see an abstract class is any class that contains a pure virtual function or destructor. And what is a pure virtual destructor or a pure virtual function? Well, it's anything that looks like this, right? And so all you have to do to answer that question is come in here and say this line of code right here. Look, I even told you it's a pure virtual here. I'm pretty sure that these comments were included. So that's the answer to number one. This line of code makes this class abstract. Therefore, you cannot instantiate this bucket. And as I said previously, if you failed to, I mean, not that you failed, right? Because I had done this as a mistake. I had capitalized is integer, right? And for some of you who were trying to remain consistent, you were getting those abstract class errors, and that's because if you didn't leave that I lowercase, then it still thinks all of the classes that inherit from it are also abstract classes, unless of course you successfully override that function to tell the compiler that this is no longer an abstract class. So then the second one here, I'm asking you, and I kind of talk about this a lot. It says these template bucket classes are equipped to store any type. Unfortunately, sort may not always work with custom data types. So I ask you, what operator overload is required for custom types so that the sort will work? And so obviously I don't have a sort here, but if I were to just type some pseudocode, you would have your sort function, right? And then somewhere in here you'd have like a loop. You'd have a loop maybe. Depends on what sort you use. And then in here you do a check. And you say if A is less than B, or if you say if A is greater than B, something like that. And so if these happen to be a class, if this operator is not overloaded here, they will not work. So you'll get an error. And so if you said this less than or greater than, you would have gotten full points for that. I also gave full points for another operator. I gave it for the assignment operator, because somewhere in your swap function, you would say something like A is equal to B. Now this won't give you any compiler errors, but if that class we were working with had pointers in it, then we'd get some memory leaks, and I kind of count that as the program not working. Okay, so if you put either the assignment operator or you put the less than or greater than operator, you would have gotten full points for that. I think the stream quality is good. I'm kind of having the same thing here where I get kicked from the chat and stuff. So if I'm getting choppy or anything, just pause me, okay? Please tell me that I'm choppy or not, because I think I may be able to fix that. So that is the answer to that one. And then lastly, I ask you, what constructor can you call to initialize a type variable to some default value? Thank you for confirming that, Sibe. I kind of see people drop in and out of the stream, and, you know, I never know. Though I am watching myself. So this last one here says, what constructor can you call to initialize a type variable to some default value? I gave you the correct answer is type. Okay, so I actually didn't specify what the template type name was, right? So that might have been confusing to some people. Let me see if I did it anywhere in our examples. So not there. Here we did it, right? So you notice here that we're using this type constructor, and that's what the name of the template type is. So in the case of this assignment here, I said a type variable. What constructor would you call? Well, it would be type, right? It would be this one. Whoops. It would be this. So you got full points if you said that. And then I was pretty lenient. If you said even default constructor, I gave you points as well. But if you said anything other than type or default constructor, you're going to get deducted for that. So just remember those for the test. And check your grades. You know, if you've got any questions about what happened, I was pretty detailed with the comments that I posted. You'll see, you know, what class, what function, you know. So if you want to figure that stuff out, let me know. And so that's the end of assignment 7 stuff. I'm going to talk just about a few things Web Campus wise before we get started. I updated the notes on the single link list, so I know some of you might want to look at those for the test. I finally got to that, okay, and they're pretty similar to what was on YouTube. I changed them up a little bit. But these are pretty much all the singly linked list, the linked list notes that we'll need to know for the test. So those are there. And then the last thing I want to talk about is this lockdown browser thing. Once again, we're using it this time. This is the first time I'm making my students use it, but I see I want to test you guys for your knowledge, and so I just want to ensure that it's not super easy to, you know, pull up Bobby and run the code or call your friend on Discord, that kind of thing. Not that I don't trust you, but it has been requested by the computer science department, and I understand why we should do a test like this. So no webcam required at all. Just please download Lockdown if you don't have it. Okay, I gave you this link, and this should take you where you need to go, and if it doesn't, please talk to me. And then I also uploaded a quiz, okay? So if you just want to test this, it's for no points, okay? I just want you to kind of go in here and run Lockdown Browser to ensure that when I load up test 2 here, that you can see and take that test. You know what I mean? I'm giving you an opportunity to test your software, I guess. So please do that. Other than that, we can go ahead and get started on our review. So if we go look in the test review, I'm just going to check test 1 to see what I did. So I'll put an answers folder in here later today, where I'll upload the answers to what we've discussed here, just like I did last time. But if we happen to take a step back here, I'll zoom out a little bit. Look in test 2, I've uploaded 2 things. For one, I've uploaded these practice questions. These are what we're going to go over today in the same kind of format that we did last time. I'm going to ask the questions, and for most of them, I'm going to appreciate it as long as the answer is short. If you guys want to throw your answers out there in the chat, makes it more fun for me. So if you're willing to do that, that'd be awesome. I've also thrown in this practice coding question. Okay, this looks a little bit like an assignment. But I just wanted to make sure that you got some good practice in for some of the things that we talked about. So it's only 2 pages here, but plus the main skeleton code that I gave you. But if you just code up this class, maybe we'll take a look at it at the end if we've got time. And if you want to check yourself, there's a solution.cpp. And I want to say that this is meant to mimic, say, maybe the last question on your test, though the one on your test will be easier than this assignment, okay? Or not assignment, but this review. It'll be easier, so don't take this. This is just a good practice for everybody. So now that's all said and done, let's go ahead and get started on this. I'm going to download it so it's easier for me to kind of navigate here. All right, and let me see, I can probably make this wider just a little bit. Looks good. And then I would like to get rid of this. Am I allowed? Thanks. Okay. So what do I say here? Well, we've got plenty of class code. We've got some assignments. And so though these questions are kind of general, you know, this is not the exact question you'll see on the test. Maybe it is, maybe it's not. They're just designed to kind of help you think about what you're going to be talking about or answering for on the test. So we're going to start with virtual functions. So hopefully you guys remember a little bit about that. That was a while ago. And so let's just jump right into it. Does anyone remember what kind of polymorphism that we use with virtual functions? And there's only 2 of them, right? There's compile time and there's runtime. And so this one is kind of, I mean, in my opinion, it's the easiest of them to remember. Oh, I'm seeing some chats here. Let me pull up my other thing. Here we go. Runtime. Yes, the answer is runtime. Red Rose, we had agreed that templates can be runtime and compile time. And because the template thing is a little iffy, nothing like that will be on the test. But you do need to know what kind of polymorphism virtuals are. And it's runtime. And why is that? Because we're working with pointers, right? We work with pointers. And the pointers are allocated during runtime. And then it's during runtime how the code determines, you know, which function to call. What object are we working with, right? So I kind of ask you, what is the syntax for a virtual function? Well, that is really easy, right? All you have to do is come look at some notes, which we've got plenty of them. I just want to, you know, kind of take a peek here. And let's see what, here's syntax, right? Really, you just kind of put virtual in front of whatever the function is. If it happens to be a pure virtual, then it's going to look like that bucket, right? It's going to look like that bucket where we might do something like equals 0, right? So that's the syntax. This is the wrong thing. Okay. Right, so I actually kind of just answered both these questions, right? You add a virtual in this case, and in this case you add a virtual keyword as well as equal to 0. So what is an abstract class? I kind of already answered that at the beginning of class, right? That is any class that contains a pure virtual function. That's it. Okay, so if it's got a pure virtual function inside, then it's abstract. And so then I also answered this at the beginning of class, right? When we were talking about assignment 7. Can this abstract class be instantiated? No, it cannot. Okay, it's like an imaginary. It's just kind of like something for us to base our work off of, right? So no, they cannot be instantiated. This one I won't ask you guys to answer. I'll kind of just give you the idea of how you might answer this one. Why do we use virtual functions? Well, roughly, it's that we can store objects of derived classes into the base class pointer, right? So we can kind of have a whole set of different things, different objects that have different function implementations, right? Because the functions have been overridden in the derived classes. And just like in assignment 5 extra credit, right, when I had asked you guys to convert that assignment 3, I believe, into an assignment that uses virtual functions, you kind of, at the very end, it was very satisfying, at least for me, how you can delete all of those if statements, right? So why do we use virtual functions? It allows our code to be more general, right? We don't have to have all these if statements. And it allows us to access functions from a pointer of the base class. It allows us to access derived class functions from a pointer of a base class. That's why we use virtuals. Okay, so what is this one then? Consider a base class and a derived class. If the derived class contains a member function with the same name as a virtual function in the base class, and I need to change this one. And also assume it has the same parameters, right? So if it has the same name and I need to edit it, and if it has the same parameters, what is it called? Just going to pull up some notes here on the side. So I want to make sure that I answered this next one. Yeah, I did. I should have. Yeah, so Red Rose says that's a function override, and that is correct, right? So if the base class and the derived class are both containing a function that have the same name and parameters, it's called a function override. If the parameters are different, then it's a function overload. Okay, it's a function overload. So nice job on that. Now I just kind of want to point this out here. So this is in the notes, and this one is kind of hard to remember because we actually didn't really practice with this. So if you just want to answer like number 1 yes or no, and number 2 yes or no, what do you think these are? So can a pure virtual function have a body? And can a pure virtual destructor have a body? So yeah, T. Peter got it right there. Yep, and that's in our notes. Okay, so and let's talk about it a little bit. So a pure virtual function cannot have a body at all. Okay, and that you can kind of look in that assignment that we were talking about, assignment 7. You can kind of just look at the skeleton code, and you can see that in the bucket class, this will not have a body. But the destructor, if a destructor is pure virtual, it would look like this. And let me kind of just give you a little bit of notes to talk about that. Maybe I already said it here. Let's see. So this is in the notes. And I'm going to tell you why that pure virtual destructor has to have a body. Okay, and why that we use them. So the reason that destructors can be virtual is that sometimes it's important which destructor is called first, right? So in the case of a player, sometimes we want to ensure that the warrior's destructor is called before the player's destructor. Sometimes things have to happen that way, especially if the derived class has a pointer in it, right? So if the derived class has a pointer and the destructor in the base class is not virtual, then you probably won't deallocate it, right? So that is why destructors can and sometimes have to be virtual. Now, the truth is, we just sometimes want an easy way to tell, like the compiler, that this class is abstract. Okay, so maybe our class doesn't really have many functions, but it does have a destructor. And so what's the easiest way to tell it that this is abstract? Well, let's go ahead and say that the destructor is virtual, a pure virtual. In that case, the class will become abstract, but it has to have a body, and the reason for that is the destructor is always called. You recall that? Yeah, so that's exactly what I said here. So it's in the notes. I'm not even going to put anything down. The base class destructor is always called. It's just like the constructor. It's always going to be called. And so that is why virtual destructors, pure virtual destructors, must have a body. And notice this part here. You might want to check the notes on that one. Or you can look at Geeks for Geeks. A definition for a destructor must always be outside of the class. It cannot be on the inside. And that's because we're doing this equals 0 stuff. So down here, if we were going to do that, we would just say, you know, excuse me while I'm copy pasting everything. Then you would have your bucket destructor, and then you would have to give it a body here. Okay, that's it. But it is specified to be pure virtual right there, so no biggie. So now we're going to move on. That's really all we've got for virtuals, okay? So please let me know if there's anything else that we need to really talk about. Overall, there won't be too much code, as far as I know, associated with coding virtuals, besides what? Having to put virtual in front of them and answering these kind of questions. So now we're going to go to operator overloading. And so what do you guys think this one is? And let me see if I saved my Geeks for Geeks. Little picture that I took a while back. Or maybe I probably just put it in the notes, I bet. Yep, so that one's compile time. That one's compile time. And so once again, I'll kind of just show you what I'm thinking about here. You come to Google, type Geeks for Geeks, C++, polymorphism. We're probably going to click on this thing here. And if you can see this, this is what we reference here. Okay, so operator overloading happens to be compile time, in which we kind of have to put a definition for this operator somewhere, right? And we kind of know. So Red Rose asks a great question, and I'm kind of thinking about this myself because if, you know, we put some pointers together, right, and allocate them during the runtime, and then call some operators, we might consider it to be a runtime. But do you recall that when we, just for example, when I always ask that question, will this function work with custom data types, right? And so, in a way, operator overloading is not runtime polymorphism because I mean, you're right. It is hard to put that in words, but the point that we're trying to get across is that all of our operator overloads, they're a type of polymorphism, right? Taking multiple forms. And all of that stuff has to be compiled at the beginning. Right, and so Red Rose says we would have to declare those operators at runtime. And so that's kind of what is going on there, is that we're specifying that this thing has many forms, but we're going to put that kind of template or that operator overload at compile time. That's when it happens. As opposed to, say, virtuals, where the thing that has many forms happens to be some dynamic memory. And so during the runtime, it has to determine where that goes. And in fact, it may call an operator overload, but the actual polymorphism aspects of that, the virtual part of it is runtime, right? Determining which class we're talking about. But then, once it determines which class we're working with, it will then pull out a already compiled and templated operator overload that we already coded, that was already compiled. And it's just able to be accessed. And so that's why this is a compile time, because we have to do it at the compile time, right? We kind of put this, it's like templates. Well, I won't say it's like templates. Templates are the difficult ones. It's more like the other one, which is function overloading, right? Function overloading. So I ask you here, what's the syntax for defining an operator overload? Well, that one is pretty simple. It's kind of like this, right? That's in the notes as well, but you would just say some type, right? Whether or not we're returning this by reference, and then we have to specify that we are working with an operator. So we've got the operator there, and then we put whatever the operator is, and then whatever parameters it takes, and then whether or not it's constant or not. You would only do that inside of the class, however, and then you would give it its body. Actually, no, you do it on the outside of the class too. Right, so that's the syntax for operator overloads. On the practice program, you have to do two of them. You have to do, I'll have to remember which ones. I think we did a bracket or an assignment overload. We do an assignment overload and we do the insertion operator. So T. Peter asks, is there a rule of when we should or shouldn't use by reference for operator overloads? I would say the rule of thumb is when you do this one. And this one and the other one. And the reason for that is because we don't want to make a copy of whatever stream. So this is just kind of, I mean, you can kind of think about it, use some critical thinking skills in a way. When we do this one, what happens is if we return out, right? That's kind of what happens in the end here, is it takes an O stream out, and it usually takes it by reference. So here's the rule of thumb, right? If this is a copy, and then you return this by reference, you're gonna have a bad time. And the reason you'll have a bad time is because then you say return out at the bottom here, right? We've got some code here. And so when you return out, you're returning this by reference, and then it goes past this bracket, and then out goes out of scope. The destructor is called, and then you're returning nothing. You're returning kind of deallocated memory. So the first rule of thumb is if you have parameters that are going in like that, then probably for sure, not always, but you may have them going out. The reason that we should do it with these ones is because we don't want to make a copy of whatever stream that we're actually working with, right? We want everything to go to the same stream. If we end up making a copy, then we have two different streams in which we're pulling from and sending things to. So in general, just with all of the operator overloads, I would say these ones are the most important to remember. And then there's another one that I'll talk about, is this one here. Notice this one. So this one would be read only. right? Because if we don't include that reference ampersand there, then we're returning a copy of whatever is in the array, right? We're going to return a copy of whatever's in the array. But the moment that we add this, and then, so here's the two differences, right? The one difference is with that ampersand, bucket located at I is equal to 10. This works. But return a copy, right? We're going to say bucket I equals 10. This will not work, right? So that's kind of the best way I can put it, right? Is are we trying to return the same thing, or are we trying to return a copy of it? You know what I mean? Yeah, you're welcome. I think that's probably an easy way to think about it, right? And in fact, if you do this, if you say like const here, it'll get mad at you because you're literally returning like an address to inside of the object, and so it will say, hey, no, you cannot do that. This one will work just fine, and so stuff like that. So let's hop back into it here. Okay, so here's an important one. Are there any operators that cannot be overloaded as members of a class? What are they? And then, using only a few words, if you can, do you know why? Kind of what the reasoning behind that is. And I'll give you a few seconds for that. We did this in the notes as well. Yeah, so CBase says insertion and extraction. This is because there's no object on the left-hand side, and that's exactly right. That's exactly right. Right? Recall here that if we do cout object, there's no way that we can go inside of this object and then pull out the operator, because the operator is appearing before the object on the left-hand side of the object. So the object is always on the right-hand side, and that is why this operator cannot be a part of the class. Similar with the other one too. So those are only two, so be sure you remember those. So you probably know what question's coming up next. Hopefully, yeah. So what are these ones? What are the operators that cannot be overloaded as global operators? And given the explanation that we just had, why would these ones, what's the case that these cannot be global? You know, why is that? So yeah, Red Rose says the object is always on the left, right? So in this case, some of these operators, there will always be an object on the left, and so those operators happen to be three of them. There's three of them. You have the assignment operator, right? There's always an object on the left-hand side of this. You have the brackets. There's always an object on the left-hand side of those. And you have the parentheses, which is something we haven't done. Sometimes people use parentheses to change the value of the object, kind of like a copy constructor. So these three operators, they're always going to be members of the class. And you can see that up here, right? Here it is. It is a member of the class. It cannot be global. So now I'll say that every other one can, right? You have the option to. It can either be a member or it can be global, but you have to be aware that it depends on the order of the parameters, right? Red Rose asks, can we overload the dot operator? And the answer to that is no. I'm 90% sure, and if we are not too confident in ourselves, which sometimes we're not, I will pull open the operator notes just to make sure. And there you have it. So these are the 5 operators that we can't overload. One of those is the dot operator. We can't do ternary either. We can't do the scope resolution. And then these things that look like functions, they're considered to be operators. We can't overload those either. So here's a question, number 5, yes or no. Can we define new operators in C++? I won't make you tell me why. I just want to know yes or no. Unfortunately, no. Yeah, that's correct. So you can only use the operators that have already been given to you in C++. So what's the answer to this one then? If we want to give a global operator overload, or even a function, hint, if we want to give a global operator overload or a function, a global function, access to the private members of class, how do we do it? With friends, right? Isn't that nice? So we can make things friends, right? And so usually with these ones, if we're going to do something with the bucket, I don't know, sometimes I call this object, sometimes I call this right-hand side because it's on the right-hand side. You have to take this prototype. You have to bring it inside of the class. And all you have to say is, hey, this is my friend. That gives this operator or function access to the private members, or protected members in this case. So I'll kind of just talk to you about this one because it's kind of generic, but it makes our code more readable. So the question is, what are the benefits of operating or overloading operators? It makes our code more readable, and it makes our code easier to write. It's kind of a way we can, the term is abstraction, you know, so we kind of are disguising some function, or we're reducing a block of code into just one operator. And so kind of the shorthand for that is it makes our code more writable, and it makes our code easier to read. Red Rose and I have already answered this question. Are there any operators that we cannot overload? There's 5 of them. The dot operator, the ternary operator, the scope resolution operator, size of, and type ID. So I'll ask you this one then. What is the syntax difference between prefix and postfix? What is the syntax difference? Do you remember that? And then I ask you to consider it for both of these, right? If they happen to be members of the class, then they won't have the object as a parameter, but if they are globals, then they will take the object as a parameter. So Red Rose is close, right? There's a difference in the parameters. Do you remember what the difference is? And in fact, they take, of the parameters that are used, they take the same amount, which is the object. But one of them is taking some extra parameter, and that parameter might not be used. It's kind of just there to say, hey, compiler, this is the prefix one, and this is the postfix one. Yeah, CVA says a dummy type, and Aaron nails it, right? So that's exactly how you do it, is it takes a dummy int parameter. It takes a dummy int parameter. So whenever you do that, I gotta put that down. Whatever this function returns, right? It could be void if you want it. Usually these would return, say, maybe the type of the class, so like a bucket. Might be a capital B. So it would return some bucket, and then it would be the operator plus plus. And so the prefix would just be like that. And then the postfix would be it takes just an int in here. That's it. And the int doesn't even have a name. Okay, so that's kind of the word I look for, dummy int parameter. Right? Exactly right. So just remember that. That's how we make them different. And remember that the prefix is the plus plus object, and the postfix is the object plus plus. And I just said this, right? This isn't even really a question. Remember that the order of the parameters matter. Okay, so if you've got string plus int, it's not the same as int plus string. But if you happen to code both of those, like we did in that matrix assignment, you can kind of just swap them around, right? So if you end up coding one of them, you can probably just call that operator and the other operator, in which the parameters or the operands, that's the term. If you haven't heard that before, I'll just kind of talk to you about that so I'm not speaking gibberish. If you have a plus b, a and b are the operands. So that's what I'm talking about, right? So if you've got the string plus int, and then you do int plus string, you can just use code for one of them, but in the other one, you'll just swap them around, right? That's all I mean. There's an example of that on assignment 9 and in the matrix assignments, right? On assignment 9, I asked you to do the less than sign and the greater than sign. And if you code up one of those, then in the next one, just flip the parameters. That's all you have to do. And then this is also not a review question. Oh, this is not a question, but I'm telling you that if the overload is a member of the class, you have access to the this object, right? If it's a member of the class, you already have access to an object's elements. But if it's a global, you're going to have to pass in the object as a parameter. Okay, so I'm just asking you to remember that, not to get confused, because it can be confusing. If that addition operator happens to be a member, or if it happens to be global, what is the difference in the parameters? So now we'll talk about templates and recursion and a little bit linked lists. We're doing good on time here. So what is the general syntax for using a template? Well, I kind of told you here. And you should be kind of fresh off the boat with this one, right? Because we just did assignment 7. And I'm sure you guys got plenty of practice with that because of all the inheritance and all of the defining things outside of the class and just copying, pasting this stuff. It's everywhere, right? So I know you've had plenty of practice with that, and that's the syntax. And so then, can we make templates using multiple types? And what is the syntax for that? So the answer is yes, we can. And we have to just kind of list them off there, right? List them off in the top. Let me see if I just pull up the notes for that real quick, because I really don't want to type that out. Right, so here's the syntax for that. Notice that the two types have to have different type names. And we're just going to separate them with a column. Now this is probably for sure going to be a test question. I know I said this before. So I'm asking you, if you're going to declare an element or an object of this class, you have to specify what types they are. How do we do that? We do it like this. Okay, so if on the test I say make a struct for a point in 4 dimensions, right, w, x, y, and z, I want you to say declare an object of that type for int, string, int, double, something like that. So be familiar with that. So I'll ask you this. I've already given you one, right? So there's 2 keywords we can use to specify the types of the template. Obviously, we're doing, in the bucket here, type name. Oh, man. I messed up. I apologize. I don't want to take away your participation. It's type name in class, okay? I thought for sure I had type name here. I usually default to that one, right? But if you don't want to use type name and you prefer to use class, they are interchangeable. And if you're doing doubles, you can do both. Isn't that confusing and inconsistent? Yes, it is. But they're interchangeable. Sometimes all you can do is rely on yourself, right? And sometimes I can't even pull through there. All right, so I kind of already jumped ahead on this one, right? Assuming you have a template class of a single template type, how would you declare an object of that class? Well, obviously, you've had plenty of practice with that, right? It's kind of just like this. Take away the scope resolution part of it, right? I'm just talking about you have to put the less than greater than sign, the little side carets, whatever you want to call these, and you have to include whatever type is in there. If it's 2 types, then you start listing them off. 3 types, list them off. 4 types, list them off. So, yeah, I already answered that. All right, so I'm asking you, we answered this at the beginning of class, but let's just see if we know what we're talking about. Assuming you have a generic template type called T, how can you initialize a variable of this type T to some default value? What is the call for that? Exactly. Red Rose got that exactly, right? We talked about it. If I have TA equals T, right? That's how we do that. So just remember that. And you just call the default constructor for this generic type. That's it. And on that assignment, by the way, there was an array. You had to go through the entire array and initialize each object to T. You would have got partial points if you did only one of them, but you have to assign this constructor. You have to assign it. I mean, I suppose that this constructor will be called in general. For example, if we're working with custom data types, but in some cases when we're thinking about ints, you know, C++ is kind of unpredictable. An int is not a class, and if we use a template type with an int, what are the odds that, you know, the integer is initialized with a 0, and what are the odds it's initialized with whatever garbage value was sitting in that memory before, right? If you run it on Sally and Bobby, is it different? Stuff like that. So even though in a lot of cases the default constructor will already be called, this is just to be safe, to be super extra safe, because what happens when we assume? Well, I won't say it, but assuming is not always the best thing to do. So what's this last question here? Okay, yeah, so I'm not going to ask for participation on this one because we've talked about this plenty, okay? And so I might, on the test, show you a block of code of a template function. And I'm going to say, hey, will this always work? If not, why and like where? What operators are going to cause it to break, okay? So I'm asking here if you have a template function that adds 2 objects of the same type using addition, using this operator. Will this function always work no matter what? If not, what needs to be considered? You need to say, we need to consider an operator overload for the plus. If it's the less than, you have to say an operator overload for the less than. And it might even be a little more involved, right? There might be a less than, a greater than, an assignment, and an addition in it. So just kind of pick them out as you're going through the code. Go, will that always work? All right, so you guys can answer this one for me. Moving on to recursion here. And feel free to stop me and ask me to go back if you need me to. What is the general definition of a recursive function? So I'm not asking for those bullet points I put down. Just like in an English, yeah, so that's exactly what I want to see. So T. Peter nails it there, right? A recursive function is a function that calls itself anywhere in the function. Or if function A calls function B, and function B calls function C, and function C calls function A, then function A is recursive still, okay? So if somehow it will call itself, then it's recursive. So what I mean, this one's pretty easy, right? But let's just, for the fun of it, what is the purpose of having a base case in the recursive function? You know, what do you guys think about that? Got some water here. That's a great answer, right? Red Rose says not to crash Sally. CBase says so there's not a Stack Overflow. That's exactly right. T. Peter says you can eventually stop. And Awful says to know when not to call itself, right? So all of those are correct. In that, if you don't have a base case, you're just going to infinitely call that function, and then eventually the stack, which I had described before, though you don't need to know about yet, it will overflow with function calls, and your computer will run out of memory. So just to stop an infinite loop, right? So then what does the reduction operator do? Let me look at the other ones here while you're answering that. Yeah, Red Rose got that one right as well. That one gets you closer to the base case, right? A reduction operator will take you closer to the base case. So in the next function call, you have to do something different, right? To change the state of the function the next time that you call it. So what is that reduction operation? There might be a few of them. But anything that's changing the parameters or the global variable in this case, that's your reduction operator. So I'll kind of answer this one for you. It's kind of a general answer. Why would we use recursion instead of iteration? Because in most cases, iteration is more efficient. It's more efficient, both memory-wise and speed-wise. So why would we use recursion? And the generic answer is some problems are much easier defined as recursive functions. And I know we haven't had a good example of that yet. And I haven't produced one yet either. But sometimes you'll be sitting in front of your computer. For example, here's one. We've got a little bit of time here, so I'm just going to take a small sidetrack, and I'm just going to show you, because this was a real thing that happened to me. Let's say you're on Amazon.com, and you're like listed some products, right? What products will this person buy? And so what the products are is they have weights, right? So say you've got something like, clothes, electronics, and something else like maybe, hair care, something like that, okay? So these are just examples. And so this is kind of an array, and then in here are going to be some values. So let's say that's a 2, that's a 5, and this is maybe a 7. And so what this describes is the importance of these categories to this person. So in this case, Amazon knows, based off of the data it's collected, that hair care has a higher importance value than electronics. And then electronics is more important to you than clothes. And so when it recommends something to you, it'll put the hair care products first. And so now, the question I pose to you is, say you had a vector, this is what we'd call it, like this, where they're all ones. And so what is the appropriate offer order for that? If this is X, category X, this is category Y, and this is category Z. So I'm not going to spend too much time on this, but I'm going to ask you, go home and try to code this with a loop. Okay? Go home and try to code this with a loop. Write a function that generates all valid offer orderings given an array, right? So in this case, you can get X, Y, Z. You can get Y, X, Z. Let me do all of them. You can get X. So x, zy, and then you get the y, zx, and then you get the zxy, and you get the zyx. So these are all valid based off of these values. And the complexity of this happens to be n factorial. So in this case, it's 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. And you can see I have 6 total valid things. And so write some code to do this, okay? Try to use a loop. If you can do it, I'm sure you can. But recursion will make this much easier. Red Rose asks, could you do a while loop with a reduction operator that gets you closer to the while condition? And so I would say yes. The thing here that I want you to think about when it comes to recursion in general is it kind of has a tree structure. And so loops are very good at doing this thing where it just does the same thing over and over and over and over again, right? So the loop kind of looks like this. This is just my interpretation. And so the loop has this kind of advantage to just doing this, you know, this is kind of like, this is not what I wanted. Here it kind of just goes in a circle. I mean, it's just going in a circle over and over again. That's what I mean by this. But in general, problems that are kind of recursive break out into kind of trees. And the trees is what makes the iteration part of it hard. And so in this case, you know, you've got like you've got a blank offer here. And then what does it break into? Well, you can do the x, you can do the y, and you can do the z. Right? So in here then you've got the x, the y, the z. And then from there, these then break out into more trees, right? Here you've got the y and the z. Here you've got the x and the z. Here you've got the y and the x. And so then as you follow it down, you're going to end up with an offer ordering along this path. You're going to end up with an offer ordering along this path, an offer ordering along this path. So that's what I think about in general, is how does the problem break out, you know? Is it kind of something that can just be repeated over and over and over again? Or does it kind of fan out into this overly complex, you know, grouping of smaller cases, right? So if I ask you this, it would be because sometimes problems are easier defined as, you know, smaller versions of itself. They're sometimes easier to think about it this way. And that's it. And so I won't ask you this one because we already talked about it, but a recursive function you coded is infinitely calling itself until a Stack Overflow occurs. What 2 things might be wrong with your function? 1, you have no base case. Or 2, you have no reduction operator. Or 3, both, right? If you have nothing to take you closer to the base case, you're not going to get there. And if you don't have a base case, you're not going to get there, right? So that's what's going on there. All right, so let's see if you guys remember this one. You have a recursive function that either returns on a base case or makes a single call to itself at most. What kind of tree can be used to represent this calling sequence? Now, if you don't remember what this one is called, yeah, okay, Red Rose got it. Sorry that I assumed there. I should not have assumed, right? It's a unary tree, right? Because un is for 1. So this one calls itself twice. So what is that tree called? At most, it'll call itself twice. What will the tree be called? Binary. That's exactly right, Awful. Yep. So as you go up, if you can't remember the un in the binary stuff, you can say 1-ary, 2-ary, 3-ary. I won't judge you for that either. I'll give you points. In this case, this one is like a triary, right? I guess we'd call it trinary, but it's breaking out into three ways. All right, so now we're on the last little bit here. Now, here, I'm going to kind of pick and choose on these, okay? So pay attention because we've only really talked about the singly linked lists. And so for any coding that you have to do on the test, it will be with a singly linked list. Most questions, I've answered some questions about doubly, so you might be, required to answer just a generic question, but you won't required to do any code as far as circular linked lists or as far as doubly linked lists. All the code will only be with singly linked lists. So I'll ask you this: how many directions can you traverse on this one? And then how many directions can you traverse on a doubly linked list? Of course, maybe simple questions, but this is a review, and it is important. 1, 1, and 2, 2, right? Yep. So on a singly linked list, you can only go in one way. You can only go down. In the doubly linked list, you can go down and up because you've got that previous node there. So I ask you to do this. Write the code needed for a single node in a singly linked list. Well, that one's easy. Let me just kind of go to my notes. Pulling up a big picture here. Where is that code? Oh, it's right there, isn't it? There it is. There's your code. Right, that's it. You've got the element, and you've got the information telling you where the next node is. All right, so this question, I most definitely might ask you this one, okay? We did talk about it. Assume you have 4 total linked lists. So you've got the singly linked list, the doubly linked list, and then the circular stuff. Now, let me just tell you, in a circular linked list, it just goes in a circle, meaning that the end node is pointing at the starting node. And so really, there's no beginning and end. It's kind of just a circle. So hopefully that makes sense. So with these in mind, which of them required to have at least one pointer that points to, well, okay, I'm sorry, I'm getting ahead of myself. All of these lists require some access pointer. We usually call it the head, right? These lists all need an access pointer. But which of them require the pointer to be looking at the very start of the list? Of all 4 of these. There's only, which of them? I was about to give more information there, but we did talk about this. The non-circular singly linked list requires it, right? Because if you think about it, in a doubly linked list, you can always go forward and you can always go backward. In a circular singly linked list, you can just keep going around the circle, right? You'll never run to the end. And in the doubly linked list, it's both, right? You can go both directions and you can go endlessly in a circle. But on the singly linked list, you always have to start from the beginning. As we learned when we were speedrunning the swap function, right? When we were coding that swap function, whenever I wanted to go through that linked list, I had to start at the head. I had to start at the head and go through node by node. And then I had to start back over at the head and go through node by node. So it's this one. It's just this one. And the doubly is because you can go in both directions. That's why. If you're at the end, you just go backwards. All right, I think you guys can answer this one. Though I haven't directly asked this question before, I think you know enough. So if you're inserting an item to a singly linked list, how many pointers do you have to update? And then I kind of ask you in general terms, what do you think what would you call the pointers? You kind of remember in the swap function, I was using the left and right syntax. So maybe you could say maybe the new item and, the left item. But let's just start with how many pointers. So do you guys have any idea how many pointers you need to update if you're just inserting one item to the singly linked list? Oh, I even gave you the names, huh? T. Peter says 2. That's exactly right. That's exactly right. And so remember, you just have to think about it. And so if you're inserting an element to that linked list, let's kind of pull open my diagram here. That's not the one I wanted, this one. So let's say I'm inserting an element here. Hey. So no matter where I insert this, if we just start with these two, and I'm going to put one here, I have to update the previous node. So what did I call it here? It says the item before the inserted one is called current. So in this case, this is current. I have to update current next. And I also have to update new node next, right? Because then the new node will be pointing at number 3. So if I'm putting in a 2.5 here, node 2 is going to have their next updated, and node 2.5 will have to have their node updated to look at number 3. It's always the same here, because if it's the head, you're going to still have to update the head. So instead of current next, you're going to update the head, and then you have to update the new nodes next. Okay, so it's just 2. So I'll kind of just talk about this one. What are some benefits of using a linked list? Well, we kind of already talked about it, but it's easy to insert and delete, right? Whenever we do a contiguous dynamic array, we have to do this annoying thing in the buckets. I know that you guys did it. We've done it a million times, where we have to allocate a new array, copy over the old elements, insert the new element, delete the old array, assign the new array to the old array's pointer, kind of stuff like that. With a linked list, you can just kind of pull out a node and put it in there, you know what I mean? So deleting it, super easy. Inserting it, super easy. Disadvantages are that it's slower and it's more memory intensive, right? We kind of have to go searching. Though, you could keep the list sorted, but you're going to always have to start from the head node, depending on what kind of linked list we're using. It's slower and it uses more memory. And so here for these, I would just check the notes. Okay, what is the code to insert at the end of a singly linked list, and what's the code to delete an entirely singly linked list, right? So all the code that you'll need to know, and I will double check to make sure, is probably here in these notes here. All right, so kind of what's the code here if I want to insert a node at the head? All right, well, I got to allocate it. Right, I gotta allocate the node. I have to assign the element into the node's data. And then I have to say, hey, the next one looks at the head. And then I have to say the head is now the new element. That's it. Probably not even this size thing, right? This size thing is only here because we're doing a class, right? If we're just talking about in general, it's these 4 lines of code. We might ask, do a tail insert, right? In which you're just going to have to kind of loop through. And then I ask you, what's the code to delete a list? Well, we can do a few things. I might type up a real quick recursive one with the 5 minutes we have left, just so I can show you what that is. But if you look here, here's some code to delete an entirely linked list. Right? While the head does not equal null pointer, save it in a different node, move the head to the next node, and then delete that old node. And just do that. If we were going to do a recursive one, I'm going to call it clear void clear list. Kind of like clear deck. But this one will take a node, node n. So I'm just going to kind of wave my hands here because we're at the end of class. So base case I'm going to check for is n equal to null. Or null pointer, whichever one you're using. If so, let's return. This would be our base case. Else, let's kind of do this thing here where we say node, I don't know, I'm going to call it a save node in this case, is equal to n next. So save the next node. And then we're going to delete n. And then we'll call clear list on save node. And that's a recursive way to delete a list, where we just break it into node by node. Here's even a better one. Or I don't know if it's better, but you can tell me what you think. I made it shorter. I want to make it 3 lines here. I really want to make this 3 whole lines. Look at that. So here's our base case. If n is null, let's just return. And then we'll recursively call down on the next. And then when this is done, it will return out of this call, and then we'll delete n. And so it will kind of go backwards. It'll go all the way to the bottom and then just kind of delete its way back up the list. Kind of like a fruit roll-up or something. So that is that. Let me just kind of look at that review sheet. We are at the end of class, but I think we got through the whole thing. Yes, we did. So I'm just going to make some wrap-up comments here. I'll put up all the answers to these today. I'll probably make a little edit to that one question that I had a problem with. Check this thing out, right? This is just like a mini assignment. Like I said, the test one will not be as hard as this. But it will give you good practice with everything. There's a little bit of recursion, a little bit of operator overloading, a little bit of templates, that kind of stuff. As well as the rule of 3, right? We kind of talked about that before test 1, but the assignment operator overload made our lives hard. But now, it's not as hard because we know how to overload operators. So check this out. Solutions here, you know, as long as it works and there's no memory leaks, whatever you come up with is fine. Please check out your lockdown browser. I want to make sure that works. Come prepared for 11:30 on Wednesday. I'll be available. Send me some messages. I can help you answer some questions if you'd like. And that's what I got for you. So thanks for coming to the stream today. Thank you all for answering questions with me. Makes my day, excuse me, I've been drinking too much tea here today. As I was saying, it makes my day better to see you guys chatting with me. So I hope you guys have a great day. Send me a message if you need. Office hours are in 15 minutes. And I will see you guys not on Wednesday, though I'll be available during Wednesday, but I'll see you on Monday. Yep, thank you.